So we're talking more about chain rule today, and just some different aspects of it. Okay. So we're just going to jump right into examples because nothing's really changed, nothing new for the chain rule. Different variables in this case because we have r is equal to 2 theta times the square root of secant theta, and we want to find dr over d theta. Okay, so what we're going to have to do is, if you notice, there's a product here of 2 theta times the square root, okay? And then the square root, inside that, we have the secant theta. So that's why we're going to need the chain rule. But even before we even start the derivative, we need to rewrite this. So this function becomes r is equal to 2 theta times secant theta raised to the 1/2 power. And so now we're ready to take the derivative, okay? So dr d theta, and we're going to have to apply the product rule. So 2 theta, the derivative of 2 theta with respect to theta would just be 2. Okay, so we have 2 times, and then secant theta raised to the 1/2 power, and then plus, then that first function, right, which is 2 theta, times, and now we got to take the derivative of this, and we got to apply the chain rule because we have an outer function and an inner function. So we're going to have to apply the power rule for the 1/2 power function. So that means it's going to be 1/2 times secant theta raised to the negative 1/2 because I need to subtract 1 from that power. And so this part right here is just the derivative of the square root function, or raised to the 1/2 power function. And now we got to take the derivative of this inside function, which is secant theta. And so the derivative of secant theta is secant theta tangent of theta. All right, so now we're just going to be doing some cleaning up. So dr over d theta is equal to this. Nothing we can clean up on this one, but there is some stuff we can do here. Okay. So this is 2 times secant theta raised to the 1/2. Now, we have 2 theta, but we're also multiplying by 1/2. So this is just going to become theta. So plus theta. Now, we have secant to the negative 1/2, but this is secant theta to the first power. Okay, so we're going to be able to combine those, and we would add the exponents. So this is going to make secant theta to the positive 1/2 power, because there's a positive 1 power right here for the secant theta, and then times the tan theta. All right, now we look at this and we go, okay, now we see some things that are in common. So secant theta raised to the 1/2. So dr over d theta, we can factor out of this a secant theta raised to the 1/2 power, and then we would have left over 2 plus theta tangent of theta. Or if you wrote this without fractional exponents, you could rewrite this as dr over d theta is equal to the square root of secant theta times 2 plus theta tangent of theta. Okay? And that would be the answer for dr over d theta. So for this problem, we want to find the value of f, and we haven't seen this lately, but this is f of g prime, okay? So it's f of g, so that also means f of g of x. So whenever we see this, we have to remember fog, okay, of x, and this is equivalent to f of g of x, okay? So we want to find this. We want to find this derivative, right? Okay, and so what this means is if we want to find, and well, hold on, let me back up, okay? So we have f of u. We don't have f of x. We have f of u, and we don't have f of g of x, right? We have f of u. But over here, this is telling me u is g of x, okay? And g of x is 1 over x squared minus 1. So g of x is really x to the negative 2 minus 1. And we want to find this at this value of x equals negative 1. Now, this is going to be like similar to some problems you're going to see on homework. And so that's why I'm showing you this. Okay, so we got to realize what the heck all this means. Okay, so there is a couple ways of doing this. I'm going to show you how to deal with it with the u's. Okay, so we're trying to find this derivative. So f of g prime of x. So what this really means is that we're trying to find f of g of x prime, okay? Which, if to take the derivative of this, this would be f prime of g of x times g prime of x. Okay, so now we're going to be doing some substitutions, okay? So g of x, this statement right here is telling me u and g of x are the same thing. So this g of x, I'm going to replace with u. Okay, so we want to find f prime of u, and then times that by g prime of x. Okay, so how is this helpful? Well, all I got to do is take the derivative of this with respect to u to find this, okay? So to find this derivative right here, all right, this is going to be equivalent to, and if you look at f of u, it's a power function, so it's being raised to the 2 power, all right? So and then inside that second power function, we have a quotient, okay? So this becomes 2 times u minus 1 over u plus 1 to the first power, which we don't need to write, okay? And that piece right there is just the derivative of the outside function. And now we got to take the derivative of this inside function, which is, of u. So then this would be the derivative of the top would just be 1 times the bottom, which is u plus 1, minus the top, which is u minus 1, times the derivative of the bottom, which is 1, all over the bottom, which is u plus 1 squared. All right, and then, okay, so this right here, and let me grab a different color. All of this right here is my f prime of u, okay? Now, I also need to multiply this by this g prime of x. Well, g prime of x, I would just use this one, okay? So this becomes negative 2, so negative 2, x to the negative 3 power, and that is g prime of x. Now, we want to find this at x equals negative 1, all right? And so I'm going to clean this up a little bit because we can clean this quotient up a little bit. And so this becomes, and I'm going to bring the 2 up with this numerator, so this becomes 2 times u minus 1 all over u plus 1, and then multiply that fraction, and then this numerator becomes u plus 1, and this becomes minus u plus 1, all over, and this would be u plus 1 squared times, and this x to the negative 3 could be really written as 1 over x cubed, so this could be multiplied by negative 2 over x cubed. All right, so now what we can do is we can clean this up a little bit more. So this is just going to be 2. So what we have is 2 times u minus 1 over u plus 1 times 2 over u plus 1 squared times negative 2 over x cubed. All right, cleaning this up even more, we can bring it as one fraction, and then this becomes negative 8 times u minus 1 all over u plus 1 cubed times x cubed. All right, now we want to find this at x equals negative 1. Okay, so a couple ways you can do this. and I'm going to tell you what I think is the best way, okay? So a couple ways you can do this is you need to switch this because we're trying to find it at x equals -1. So one way that you could do this is replace all of these u values with 1 over x squared minus 1. You could do that, and then this would be all in terms of x. Now, I think that's going to be a little bit harder because you're going to have some complex fractions and you're going to have some other things. I think what's easier is we have u in terms of x. So if x equals -1, because we have a formula for u is 1 over x squared minus 1, we could use that to figure out the u value when x equals -1. And that's how I'm going to do it, okay? So I'm going to figure out, okay, what's the x value and also what the u value is, and just plug each of those in because u is determined by the x value, okay? Because u is equal to, okay, 1 over x, which we know is -1 in this case, squared minus 1. So that'd be 1 over 1, which is 1 minus 1. So u comes out to be 0. So what this means is when x is -1, u must be 0, okay? And then what we can do is just plug all these values in, okay, into this. Because the f prime, the fog prime of x is determined by a u value and an x value. That's how we wrote it, okay? So what does all this mean? This means f of g prime of x, not at x. We're going to find it at -1. We're finding a specific value, not the formula, okay? We just found the formula. So -1 is equal to -8 times 0 minus 1 over 0 plus 1 cubed times -1, because x is -1, not 0, cubed. All right, so this is -1 times -8, and that would give you +8. And this would be 1 cubed, which is 1, times -1 cubed, which is -1. So this is 8 divided by -1, which would give us a value of -8. So we found the value of f of g prime at the value at x equals -1, and it turns out to be -8. All right. This problem is a little more complicated because you're thinking of f of u. You're not writing f of g of x, right? But you got to realize u is g of x, okay? All right? And there's other ways you could do this problem. Okay, this is not the only way. I think this might be the easiest way to look at this problem, okay? But there are other ways to do this, and I'm aware of it, okay? And the last example I want to do with you guys is an example using table values for different functions. Okay, so if h of x is equal to f of x plus g of x, find h prime of x and h prime of 3. So let's first find h prime of x. So h prime of x, because this is a sum, it's just f prime of x plus g prime of x, okay, which means h prime of 3 would have to equal f prime of 3 plus g prime of 3. And so we just have to use the table. F prime of 3 is 0, plus g prime of 3 is 1/2. And so 0 plus 1/2 is 1/2. So h prime of 3 is equal to 1/2. And we're done with that problem. Okay. So how about if it's a product, right? If it's a sum or difference, the rule is you just take the derivative of each one individually. Okay. But that's not true with a product, right? We have to apply the product rule on this one. So h prime of x on this one is equal to f prime of x times g of x plus f of x times g prime of x. So then h prime of 3 would equal f prime of 3 times g of 3 plus f of 3 times g prime of 3. So that makes h prime of 3 equal to, So f prime of 3 would be 0 times g of 3, and g of 3 is 1, plus f of 3, so f of 3 is 4, times g prime of 3, and that's 1/2. So this h prime of 3 would equal 0 plus, and 4 times 1/2 would be 2. So h prime of 3 would equal 2, okay? And so that's that one. That's what if it's a product, okay? Let's go to see what happens next, okay? So let's turn the page. So what happens when it's a quotient, okay? So h of x is defined as being f of x over g of x. So h prime of x is equal to f prime of x, g of x, minus, we've got to remember the minus there, okay, f of x times g prime of x, all over g of x squared. Okay, so once again, what's h prime of 3? H prime of 3 would be f prime of 3, g of 3, minus f of 3, g prime of 3, all over g of 3 squared. Okay, so looking these up, f prime of 3, so f prime of 3 is 0. G of 3 is 1, minus f of 3 is 4. And then g prime of 3 is 1/2, all over g of 3, which is 1, squared. So this would be 0 and minus 2, so that'd be negative 2 over 1. You know what? Made a mistake. This shouldn't be h prime of x. This should be h prime of 3. Just caught it. And so h prime of 3 should be, this whole top becomes negative 2 over 1, which is negative 2. So h prime of 3 is negative 2. All right, so let's go to the next one. So this next one is h of x is equal to the square of f of x. Okay, so we have to apply the product rule to this, okay? So h prime of x would be equal, so we got to take the derivative of the second power function, which would be 2 times f of x raised to the first. You would not have to write to the first. And okay, so that's the derivative of this outside squaring function. And now what I need to do is multiply by the derivative of the inside, which would be f prime of x. So cleaning this up a little bit, this would be h prime of x is equal to 2 f of x times f prime of x. And so h prime of 1 would equal 2 times f of 1 times f prime at 1. So h prime of 1 would equal 2 times, and then looking at our chart, f of 1 is 1, right? That's this one right here. Times, and then f prime of 1 is 2. So this winds up being 2 times 1 times 2, which would be 4. So h prime of 1 is equal to 4. And then the last one, that was a chain rule, right? This is the first one where we had to deal with the chain rule. And this one right here is also going to be the chain rule because h of x is equal to a composite. So h prime of x would equal the derivative of the outside function, which would be g prime of f of x, times, and then the derivative of the inside function, which would be f prime of x. So that's h prime of x. Now let's find h prime of 1. So h prime of 1 is equal to g prime of f of 1 times g prime, sorry, not g prime, f prime, right? Times f prime of 1. Okay, so that means h prime of 1 would equal g prime of, and we got to find f of 1. Well, f of 1 is 1. times f prime of 1. So we to figure this out, we got to find g prime of 1 and f prime of 1, and we get that from the table. So h prime of 1 is equal to g prime of 1. So g prime of 1 is -2 times, and then f prime of 1. F prime of 1 is 2. And so h prime of 1 winds up being the value of -4. And that's how you do these problems, okay? And today's the last day of chain rule, all right? So we're done. Like we should really know chain rule really well now, okay? We have some other functions we're gonna be looking at. Like we haven't done logarithm functions. We haven't done inverse trig functions. We haven't done some of the inverse functions yet that we need to do. And then after this unit, we're done with the rules for derivative for the rest of the year. That's it. That's all we're gonna need, okay? All right, so I have an assignment for you, assignment 4-3, and I'll have you work on that, okay? Have a great day, guys.